Okay, buckle up for this one. Picture this. You're standing in a field, on the planet, in the solar system, in the galaxy, in the local group, in the universe. And all of that could be inside of a black hole. It sounds like science fiction. Some cosmic riddle pulled from the pages of theoretical physics textbook or a late-night Reddit thread. But here's the thing. This idea, it's not a joke. It's a serious, if speculative theory proposed by real physicists. And if it's true, it could completely change how we understand the universe and our place inside it. See, black holes are supposed to be these cosmic dead ends. The end of the line. Once something crosses the event horizon, the point of no return, it's gone. Forever. Crushed by gravity into a singularity of infinite density. That is the official story. But some scientists aren't so sure it ends there. Because there is another possibility, one that flips the script. What if black holes don't just destroy things? What if they also create? According to a few radical but mathematically grounded theories, when matter collapses into a black hole, it might actually be spawning a new universe on the inside. A universe with its own space, time, and physics. A universe that expands outward just like ours did at the Big Bang. And here is where it gets truly mind-bending. What if that's what our universe is? Not just inside of a black hole, but the inside of a black hole. Born from the collapse of a massive star in a higher dimensional cosmos. A cosmic ration doll with universes hidden inside singularities like seeds inside a cosmic fruit. It sounds wild, right? But the deeper we go into black hole physics, the more our universe starts to resemble one. And once we start connecting these dots, the edge of science starts to look a lot like the edge of reality itself. Before we can even entertain the idea that our universe might be inside of a black hole, we need to understand what a black hole actually is. Not in pop culture, but in real physics. So, a black hole forms when a massive star runs out of fuel. With nothing left to burn, the outward pressure holding the star up collapses under the force of its own gravity. It doesn't just implode, it falls inward so violently that it crushes its own atoms, collapsing space itself into a single point of infinite density, the singularity. Now, around that singularity is the event horizon, the boundary beyond which nothing can escape, not even light. It's not a physical surface, it's a point of no return. Once something crosses that horizon, it's gone from our universe's perspective. We can't see inside, we can't get anything back. It's the ultimate cosmic lockbox. But black holes don't just swallow things. They reshape the very fabric of space and time. As you get closer to the event horizon, time begins to slow down relative to outside observers. Space warps, light bends, and gravity goes haywire. It's not just extreme, it's weird. Einstein's theory of general relativity shows us that black holes are more than just objects. They are distortions in the geometry of reality. And here is where it gets interesting. Some of the same math that describes the geometry of a black hole also describes our expanding universe. Both involve a central singularity, both have horizons, and both have warp in space-time. Coincidence? Maybe. Maybe not. Because when you compare what we know about the inside of a black hole and what we observe about the shape and behavior of our universe, the two start looking very similar, which raises a disturbing and fascinating possibility. We might already be on the inside of a black hole and just don't know it. And if that possibility blows your mind, you're going to want to stick around. Drop a like and subscribe to support our channel and to stay updated on most mind-bending cosmic theories and facts. At first glance, our universe and a black hole seem like complete opposites. One is vast and expanding, filled with stars, galaxies, and life. The other is a dense, collapsed object, the ultimate destroyer. But look closer, and the similarities start stacking up in a way that's hard to ignore. Let's start with the concept of a horizon. Black holes have what's called an event horizon, a boundary you can't cross without being lost forever. Our universe has a similar feature, the cosmic horizon, also known as the observable universe. That's the furthest distance from which light has had time to reach us since the Big Bang. Beyond it, we have no idea what's out there. It's not that it doesn't exist, it's just inaccessible. Sound familiar? Next, consider gravity and geometry. A black hole's singularity warps space and time so intensely that the laws of physics break down. But on a grand scale, the universe also curves space, just in a more subtle, widespread way. According to Einstein's general relativity, mass and energy bend space-time. And guess what our universe has in abundance? Mass, energy, and accelerated expansion. Now, here is where it gets weird. In a black hole, time slows down dramatically as you approach the event horizon. And in our universe, we see something similar in the form of cosmic time dilation. Distant galaxies appear to move slower due to the expansion of space, almost as if time is stretching. Again, a familiar pattern. Some physicists have even shown that the equations describing the inside of a rotating black hole mirror the equations that govern cosmological expansion. So you have a horizon, you have the time dilation, you have warped space-time, and both systems begin with a singularity. Are we looking at two different phenomena, or two sides of the same coin? That's exactly what we are going to explore next, because there is a theory that takes this comparison to the next level. It doesn't just say the universe looks like a black hole, it says that it is one. This idea isn't just a sci-fi plot twist, it's a serious hypothesis explored by theoretical physicists like Nikodem Popławski, who suggest that our entire universe could be the interior of a black hole formed in a higher dimensional space. Sounds wild, right? But let's break it down. When a massive star collapses under its own gravity, it forms a black hole. According to general relativity, all the matter gets crushed into a singularity, a point of infinite density. But quantum theory doesn't like infinites. Something has to give. That's where loop quantum gravity comes in. A theory that tries to merge general relativity with quantum mechanics. According to Popławski and others, instead of collapsing into a singularity, the matter inside the black hole could bounce. Think of it like compressing a spring. Eventually, it pushes back. That rebound could spark an explosion on the other side of the event horizon. Not visible to us, but possibly giving birth to a new expanding universe. And from inside that universe, it would look like a Big Bang. That's the core of the black hole cosmology hypothesis. That every black hole might be a gateway to a baby universe, and our universe could be one of them. That math isn't just convenient, it lines up shockingly well with what we observe. The structure of our universe, the expansion, even the cosmic background radiation, it could all be the aftermath of a black hole bounce. What's even crazier? This theory naturally predicts the arrow of time. In our universe, time flows forward. In the parent universe, the one that created the black hole we're in, time could be flowing in the opposite direction. Let that sink in. Somewhere beyond our reality, the universe that birthed ours might be living in reverse. So if we are living inside a black hole, what does that mean for the nature of reality? And what kind of universe came before us? And if we are really living inside a black hole, what does that mean for us? Well, first, it turns everything we thought we knew about our place in the cosmos upside down. It means our Big Bang wasn't the beginning of everything, it was the continuation of something else. A kind of cosmic inheritance passed down from a parent universe, born not in nothingness but inside the collapse of a star in another larger cosmos. Our universe could be the inside of a black hole that formed when another star in another universe died, and that has staggering implications. It suggests that multiverse isn't just real, it's prolific. Every black hole in our universe could potentially contain another universe inside it. Right now, the universe could be reproducing itself through black holes, each one spawning a new cosmos with its own physics, dimensions, and timelines. Think of it like cosmic natural selection. Universes that form more black holes create more offspring universes. Over time, that could even explain why the laws of our universe seem so fine-tuned for stars, galaxies, and life. because we might be the result of an evolutionary process that favors universes capable of producing black holes. This also challenges the way we think about black holes themselves. If this theory is right, they are not the end of matter. They are gateways, and what looks like destruction from our side might be creation from within. Philosophically, it's mind-bending. It means the boundary between inside and outside, between this universe and whatever lies beyond, is much thinner than we imagined. We might be just one link in an infinite cosmic chain, born from a black hole, giving rise to others in a never-ending cycle of collapse and rebirth. So here is the real question. If black holes create universes, are we living in someone else's failed experiment or the successful spark of something greater? Let's be clear. The idea that our universe exists inside a black hole is highly speculative. It's not something you will find in every astronomy textbook or hear casually mentioned by your local planetarium guide. That's because while the theory is mathematically intriguing, it's still far from proven, and possibly unprovable, at least with our current technology. Here is the first issue. We can't observe what's inside a black hole. By definition, nothing, not even light, escapes the event horizon. That makes testing the black hole universe hypothesis incredibly difficult. If we are inside one, we wouldn't be able to detect its parent universe any more than someone inside a snow globe could prove there's a handshake in it. Then there is the problem of scale. The mass of our universe is huge, and while it's possible to calculate the conditions under which such a black hole could form in a higher dimensional space, that's still a lot of ifs. And of course, this theory relies on extension of general relativity and quantum gravity models that haven't been experimentally verified. Ideas like loop quantum gravity and the bounce back from a singularity are still in the early stages of development. We don't even have a unified theory of quantum gravity yet, so plugging that into a model of universe creation, still theoretical. But here is why it matters anyway. Theories like this stretch the boundaries of what we think is possible. They challenge our assumptions. They make us confront the limitations of our own understanding. And even if the black hole universe model turns out to be wrong, it could lead us to discover something else that's even more important. History is filled with examples of fringe ideas that, through refinement and redirection, reveal deeper truths. And whether or not we are inside a black hole, this theory is a reminder that the universe still holds secrets big enough to reshape reality. After all, the most dangerous idea in science isn't a wrong one, it's the one we don't bother exploring. If this theory is right, then the universe you live in, the one you call home, might be a memory of something else. A star that collapsed. A singularity that never ended. A black hole in a higher dimensional reality whose death gave birth to our beginning. It's strange to think about. We imagine black holes as final destinations. Cosmic trash compactors that end stories, not begin them. But what if that's the illusion? What if black holes are bridges, not endings? It makes you wonder. Every time we peer into the heart of a galaxy and see a black hole spinning, devouring radiation power, are we actually watching another universe being born, hidden behind a veil we can't penetrate? And if so, how many universes are out there? How many black holes have lit the spark of creation? How many Big Bangs are quietly happening right now? We may never know the full truth. Not with the tools we have. Not with the minds we've evolved. But theories like this remind us that reality is deeper, stranger, and more imaginative than anything we've invented in science fiction. Because in trying to understand where the universe came from, we might realize it's been looking back at us the whole time, from the other side of an event horizon. So the next time you see an image of a black hole, that dark void surrounded by light, remember, you might not be looking at the edge of space. You might be looking into another universe. Thank you for watching. Keep looking up.